On 30th, we have webinar on Docker technology. The speaker of today's webinar is Dr. Anasuya in Jadagerimath. So ma'am has 19 years of experience in teaching and education. Ma'am has done PhD from Tumkur University in 2008 and she is serving as member of societies like Computer Society of India, Indian Society for Technical Education, Universal Association of Computer and Electronic Engineer, International Association of Engineers. Ma'am has conducted various FTPs and webinars and currently working as professor in ISC department of Don Bosco Institute of Technology, Bangalore. Now I request Dr. Anasuya Madam to present her talk. Over to you, ma'am.
Good morning, everyone. It's my pleasure and it's my honor to be here to present myself as a resource person. And first of all, I would like to thank KLA Society for giving me the opportunity for this, and also Don Bosco Institute of Technology for giving me the opportunity to present myself to other institutes, educational institutes, to improve the educational relationship among the different organizations. Okay, so there is a small correction as Akila has introduced. I completed my PhD in 2018, not A. Okay, so with that, I would like to start my presentation now. Thank you, Akila, once again.
Thank you, ma'am.
Okay, this is my topic, role of Internet of Things and Big Data Analytics, that is in Industry 4.0. So in today's scenario, what we have in industry is, in IT industry is, it's Industry 4.0. So my main objective is, I'm going to discuss about the Internet of Things, then the Big Data Analytics, then what is the role of IoT and Big Data Analytics in Industry 4.0. Then I'll conclude, then I need to mention the references. And if any queries are there, we can discuss. Then before going to understand IoT and big data in detail, let us understand what is Industry 4.0. So as everybody is telling that Industry 4.0 in software industry, so what are the different components or the different models involved in Industry 4.0? So if you can see here, we have digital technology, we have robotic, cloud computing, Internet of Things, data analytics, artificial intelligence, big data, 3D printing, software as a service, sensors, algorithms, and value chain. So the consolidate or the combination of all this is called as Internet of Things as a part of Industry 4.0. Hello. Okay. Let me share screen. So as we need to understand IoT, big data and artificial intelligence. And other fields of Industry 4.0. So we'll see one by one in detail. Can you, the host can give the permission to share me the screen?
Ma'am, there is permission for you, ma'am.
Yeah, but it is not getting activated.
Yes, participant, there is some technical glitch. We'll get over this within a few minutes. Screen is shared actually.
Yeah, yeah.
Yes, you can continue. Sorry for the inconvenience, participants.
Yeah. Good morning, participants. Now, is it audible?
Yes, ma'am. Is
Yeah.
it is
Audible.
audible?
Is it visible?
Yes, ma'am. Both, ma'am.
Okay. Okay. Then. Thank you. Good morning. Myself, Anasuya from Don Bosco Institute of Technology, working as professor in ISC department. So today I am going to discuss the role of in Internet of Things and Big Data Analytics in Industry 4.0. My objectives are introduction to Internet of Things, Big Data Analytics, then the role of IoT and Big Data Analytics in Industry 4.0, then conclusion, references, and question and answers. What is Industry 4.0? So here we can see it is a convergence of digital technology, cloud computing, robotics, artificial intelligence, big data, and value chain, 3D printing, sensors, software as a service, and data analytics, cloud computing, and Internet of Things. Then question arises, where to start? Which is the basic field we need to know to understand what is Industry 4.0. So now at present, it is the convergence of all these technologies. Then to start with, we need to know about computer network, then internet, then Internet of Things. After that, we'll be able to understand cloud computing, then the remaining technical fields like digital technology, robotics, cloud computing, data analytics, AI, big data, all those things. Okay, so let us have a brief discussion or brief introduction about all these fields. Before going to this, as I mentioned, first we need to know why we need to know Internet of Things or industry. What is the role of Internet of Things in Industry 4.0? So as I mentioned, first we need to know what is computer network, then internet, then Internet of Things. Computer network started in the year 1969 with a small network which has established to share the information about their local university data. That network was called as ARPANET, Advanced Research Project Agency. So some of the university students started their networking to share the information or to share the data. So with that, computer networks emerged into IT industry. So the meaning of computer network is number of systems or different computer systems can be connected and data can be shared. On top of that, now we have internet. What is the meaning of internet? So when we were able to connect local systems within college or within one place or one city, now it can be extended to get connect with the different systems all over the globe. That is the meaning of internet network. Means to define that, it is a network of networks. It constitutes number of networks where those networks can be connected, and finally we can reach to only one whole complete network, which is called as internet. So when the internet is there, you can connect number of electronic devices and different communication systems to the internet. That will allow us to share the data, any kind of data sharing through the internet. So that's what the Internet of Things is. Then the big data is when huge devices are getting connected to the internet, the data generated is huge and which is unstructured. To analyze that, we require big data analytics. So these are the three main core objectives of today's session. One is what is Industry 4.0, then Internet of Things, big data analytics. So what are the roles of big data analytics and Internet of Things in Industry 4.0? So clearly we need to know Industry 4.0 is the convergence of all these technologies. Then question arises how to converge this. So when we have a different architecture systems which are connected to the net. Nowadays we can connect our laptop or standalone systems. We can connect our mobile phones. We can connect any kind of electronic device which can receive and transmit the data. That will become the part of Internet of Things. So when we are able to connect it, then what kind of communication and what are the challenges we face, that we are going to understand in Internet of Things. So let us see how the evolution of industry has evolved in business scenario. In the industry 1.0, you can observe during the year 1784, it is a mechanization and steam power and weaving loom. So mechanical industry was dominating the world with the industry 1.0. The second industry 2.0 is the electrical energy. The end assembly line means connection of different electrical lines and energy production with respect to electrical. Then that is during the year 1870, that was mentioned as Industry 2.0. As I mentioned, the computer network came into existence in the IT industry, that is in the year 1969, so which was mentioned as Industry 3.0. Then that started with automation, computers and electronics. So when the computers and electronics devices were playing the important role in everybody's daily life or business life or different scenarios of our life, then the same Industry 3.0 got enhanced with respect to computers as well as electronics and networking. So that's what today we have Industry 4.0, where we have cyber physical systems, Internet of Things, and networks. So this is the evolution of Industry 4.0. Then what are the things we need to be aware when we are talking about Internet of Industry 4.0? So as in Industry 1.0 mechanical devices, we can say in Industry 2.0 is electrical era. In Industry 3.0 it was electronics and control systems, that is production is automated further by electronics and IT. So as the computer networks also emerged in the Industry 3.0, now we have huge or collection of different technologies in Industry 4.0. That is nothing but IoT integration. IoT integration is Internet of Things integration. So how to achieve IoT, then what kind of integration we can do, and what are the different other fields, what I have mentioned in the first slide. So we'll see how we will be able to see the integration of all these different fields in Industry 4.0. So if at all you want to define what is Internet of Things, so this is how you can see. So it is not restricted to any particular field. It has become a common general parameter to our daily life. Then it's our responsibility to know who have invented this Internet of Things. So for that we need to know in the year 1999, Kevin Ashton coins the term Internet of Things. Sir is the first person to introduce Internet of Things to the IT industry. So here with this roadmap, we'll be able to understand what actually the meaning of Industry uh, 4.0 with respect to IoT. So here you can see during the 2000 we had if you are able to see the graph 2000 2010 20 and this is with respect to time. Okay, so RFD started in the year 2000. Then the 2010 we have vertical metrics applications like cost reduction leading to diffusion into second wave of application, that is surveillance, security, healthcare, transport. Once we are able to identify or locate the components or the products with RFID, the next stage it has become surveillance and security. The next is the enhancement of that, or the progress of that has taken after 2010, that is locating people and everyday objects, that is ability of devices located indoors to receive geolocation signals. So that started with uh, RFID tags. In my next slides, we are going to discuss what are the technologies behind IoT. So there, I'm going to discuss what is RFID. So next is teleoperation. At present, what we are using the technology for teleoperation and telepresence, which allows us to monitor and control distant objects. So maybe at present or in the year 2020, so during this pandemic situation, you might have observed how this teleoperation and telepresence has helped us in order to communicate. So in this situation, suppose if there is no internet or there is no concept of IoT, then actually we would have not conducted such kind of events. Okay, at present, at in the year 2020, we are with teleoperation and telepresence, so which allows means the ability to monitor and control distant objects. Maybe small issues may be there, means delay in getting connected or some bandwidth problem or some disturbances, but still we are able to get connect and communicate. What is the definition of IoT? Now, after defining what is Industry 4.0 and what is the main objective of my talk is what is Internet of Things. Next is Big Data Analytics. To define what is IoT, first we need to know computer networks, as I mentioned, and the internet. Then without internet protocol, there is no IoT. So by knowing prerequisites of all this computer networks and internet protocol, proceeding to Internet of Things. It is an integrated part of future internet and would be defined as a dynamic global network infrastructure. Dynamic global network infrastructure in the sense as IoT, for IoT backbone is our internet itself. How internet is working? It is with a distributed system technology where distributed files systems we are able to execute on internet. So the global network in dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols. I will pause here because we need to know more number of parameters in this case. So what is the meaning of standard capabilities or self-configuring capabilities of a node or a network? Then interoperable communication protocols. As you are aware, in a computer network, protocol plays very important role. As for computer systems, we need to know hardware and software in the same way. When you have the infrastructure for computer network, obviously the first part what we need to know is protocols. Means which are rules and regulations to drive the operations of that computer network. So when the communication protocols are designed for a particular computer network, it makes or it allows us to communicate properly between the source and destination. Interoperable in the sense when we have different kind of systems which are getting connected to the internet, then it must be interoperable. Means there is no restriction that the same kind of systems or same kind of computers or it is a vendor independent. Means it is not like that only particular systems can be connected to the internet. No. So any kind of which satisfies the standards can get connected to the internet and share the operations. Where physical and virtual things have identities. Meaning of again two parameters we need to know. The meaning of physical and virtual is, here we can create on top of internet, we can create virtual systems which made us to save our cost by implementing cloud technology. What is the meaning of cloud technology, or how virtualization or virtual term is being used in cloud computing? So after completion of this slide, I'm going to explain that. Virtual things have identifiers. The things which are not present physically can be identified on the internet virtually. Meaning is, suppose I want to get connect with my computer with another computer or another electronic device, which is not a physical device, but it can be connected as a virtual device. And we need to know what are the physical attributes required to get connect with the internet, and virtual personalities, and use intelligent interfaces which are required to connect with a different device, electronic devices to the internet, and are seamlessly integrated into the information network. So this definition is taken by the internet with one of the famous author. So in general or in brief, to know or to understand what is the meaning of Internet of Things, it is nothing but connecting a device, electronic device, which can share or which can send and receive the data, or we can say which can communicate, the device which is able to connect to the internet, means the internet network, then that will become Internet of Things. Then what we can achieve with Internet of Things? So we'll see the impact of IoT. So as nowadays we are familiar with the usage of our mobile phone with the internet. What are the things we are able to achieve, or what are the things we are able to get in? So I can download from the internet, I can get any kind of information, I can connect to the different devices, I can share the data, and I can remotely log in to the another system. So all those things can be done with the internet. Then what impact made as IoT in the real life? If you see this graph, in 2003, the usage of IoT devices were very less. I'm not going to specify the values as you can see here, but just I want to conclude that in the year 2020, it is going to be billion. So this diagram simply shows you that how a single person can connect with a mobile device or Internet of Things device. So during the year 2003, you can identify one user or one human being can connect or connected with one device. It has changed to again in 2010, one user connected with two devices. In 2015, it can increase to 4. Then now, in 2020, it is predicted by Cisco. It was predicted in the 2018 only. The prediction result shows that, so in the year 2020, it will be 1:8. 1:8 in the sense, one human being or one person will get connected with 8 electronic devices which is connected to the internet. That is Internet of Things. Now human being is connected to the IoT or Internet of Things, and the ratio is 1:8. Then what are the different devices, or how human being can make use of 8 devices and get connected to the internet? And what is the use, or how, what operations we are going to use in the year 2020? So some minimum 2 examples I can give. So when I am handling this class, minimum devices of IoT, what I required is my laptop and my phone. So now it has become 1:2. So like that 1:8, when or how we are going to operate all those 8 devices. So as and when we progress into the depth of the IoT, we are going to understand so how a human being can connect to the Internet of Things devices. Then this again graph shows that as for the Cisco, more connected devices than people. So it shows that than the people or the population, connected devices are more in the real world. So that is the scenario in the year 2020. So which was the report was released by Cisco, as the source is mentioned. So this is world population and this is connected devices. And in the year 2003, it is for 6.3 billion people, 500 million devices. If you go on checking that 2010, it is 12 billion devices to see here, it has become 6.8 billion. Then in 2015, for 25 billion to 7.2 billion. And now the connected devices are 50 billion for world population 7.6 billion. So this shows that the usage of IoT devices in our daily life. So as per the prediction, this is the scenario where we have more devices than the people or the human being. So let us know in which field or what kind of operations each and every human being is getting connected to the internet. So these are the list of applications what we are using in our daily life in 2020. That is, we have smart home, we have wearables, wearable devices. Third one is smart city. Fourth one is smart grids. Then fifth one is industrial internet. Sixth is connected car. Seventh is connected health. Then eighth one is smart retail. Ninth is smart supply chain. And 10th one is smart farming. See, in our daily life, all over the fields are major areas where and all we are using Internet of Things. Then what kind of devices are required? Then how we are going to connect? And what are the prerequisites? So so many question arises. So it's very simple. This technology has made us the usage of all those things in a very simple or simple manner. So we'll see how we are making use of all those applications one by one. So top applications what I have mentioned here is transport and logistics. This is the first area or the field where IoT is being used very huge or in a large scale. Second one is daily life and domestics. Then the third one is smart farming, health sector, and smart city. So this is how the transport and logistics. How Internet of Things is being used. So RFID is the key technology or the term you can say, which can be used to identify or locate the objects which have been transported to different parts with a geolocation where we can get connect and identify. That is how in transport and logistics IoT has become popular. Next is connected car, as you can see. So now we can automate car. Automate in the sense, no need to manually operate the each and every operations. You can program it and make it automate, and on top of that, if it is able to sense and get converged with wireless technology, then it will become automated car. So which is what we are at present we are using, driving self-driving car. So in connected roadways, so we can say Google self-driving car, where the driver is not required, but only the source and destination is given. Then the traveler can reach the destination without any problems. That is one of the important field or one of the important applications of Internet of Things. Then for domotics, we can say the different automation parts or different automations at home or office, we can say. As you can see here in this picture, security alarm, then the radiators and temperature monitoring, and monitoring and control, monitor detector, then the door control, lighting control, automatic notification, remote control, environmental monitoring, window control. So all these things can be connected and call this as one sensor network. So now question arises, then how we can achieve this? What kind of technologies are required? So as I said, so for this first, we need to know computer network concept. So on top of that, we need to know what is wireless network. So once we know wireless network, next is the sensor network. So with the one concept basics of wireless networks, we'll be able to implement sensor networks. Meaning of sensor network is the sensor is a small device which can connect and create a network. So all this network, all these different components which are connected together, sharing and communicating each other to give you a meaningful operation. Meaning is, so security alarm is the one so which has to sense if any unauthorized person is entering into your home or office, and that need to be directly send a signal to a person or who is the owner or who is there to take care of that office or home. So identification of that is done with the sensors, that is sensing the presence of human being or any unauthorized person outside the door. So once it is detected and sent to the respective uh, the person, then it is very easy to operate or to identify. So is it a situation for theft or anything, any unwanted situation is going to happen. This is how the technology is being used in our daily life to solve our some very difficult tasks. Then the radiators and temperature. So nowadays the temperature monitoring system is being used everywhere. So even as a pandemic situation, so we have some devices we to understand or to know the temperature. So everywhere the sensors are being used. So the next step what we uh, come to know is, with a computer network, with the internet protocol and the wireless networking, on top of that we need to have sensor network. So when the sensors are there, then it's very easy for the IoT, or the without sensors we cannot say that it is internet of things, because most of the operations, so what we are doing with internet of things is based on sensor networking. So here we can say door control, then the lighting control. So everything can be automated. Suppose if you want to switch off and switch on lights on a particular or at particular timings, you can set it and leave. So manually, no need to operate daily in your office or in your home. So then the automatic notifications. Automatic notifications is, so if anything is not usual, so everything is programmed there. If any unusual situations or unusual things are happening, so that is identified and sent to the notification. Where it need to give, it has to send to the mobile phone, which is integrated with this wireless network. Then the window control, when suppose if the situation or scenario is there where heavy rain is there, then you need to uh, close the window. So it has become very like your remote control, you can close your windows. So this is how office, your home, and any kind of devices, smart device, we can say smart lights, then your geyser, fridge, all those things can be electronic devices, can be controlled with Internet of Things. Then interestingly, it has made our life very easy. Suppose if you want to watch particular program on that particular every day, that particular time slot, so just program it and make the notification for the system. Then if the time is that particular slot for the program is there, then you are getting the notification. This is a very simple example, but the same thing can be used for the healthcare system, where such kind of notifications or warnings are required to maintain good health, as well as to save human being from the emergency situation. So another important field of Internet of Things is smart farming. Smart farming is where you can deploy sensors in the field. So as you can see here, so every part of a farming operation can be controlled or can be monitored with sensor network. Then how farming can be done? So this is cloud-based event and data management. So if I want to explain this, like it starts with smart analysis and planning. Next is smart control. Then the smart sensing and monitoring. Again, smart analysis, which can be uploaded to the cloud. So here, as I mentioned, cloud is the one where virtualization is the term has played important role. So I need to explain that meaning of virtualization is which is not real. As the virtual word only says that it is not real, means there is no physical object or physical system is not available. You can create virtual systems and virtual objects. How those can be created? Again, with the software which is called as hypervisor, which will create one more layer on your physical system, and it allows you to create virtual systems or virtual machines where you can make use of those systems as physical system, in the sense how your physical systems are operating in the same way virtual systems are operating. So that is again a big or another field of industry 4.0. So why that is not taken as the first presentation here? Because nowadays everybody is know about cloud computing. Yeah, any questions? I think I'll take the questions at the end of the presentation. Okay, so in cloud computing, here we need to, you need to connect with IoT and cloud. So how to understand what is a cloud? It is a service-oriented architecture where with the virtualization, you'll be able to create virtual machines and you can save the cost. Instead of purchasing independent separate systems or investing on storage and different systems, we can implement by using cloud computing. So as it is a service oriented architecture, we can say storage as a service, platform as a service, and software as a service. Meaning is, as and when we want to use some space or we want to require some storage space, we can take up with a cloud service provider and pay the fees, as we do with our electrical billing system. So in smart sensing, in agriculture field, different sensors are deployed to identify the status of the crop and the temperature monitoring, humidity monitoring. All these things are done automatically and uploaded to the cloud. Next is related to healthcare system, where we have wearable devices. So you can see here different wearable devices like your specs, your mobile phone and watch, so which can provide you the status of your health. So that can be connected to the mobile phone, and in turn it can be connected to the cloud. So example of wearable devices is, so one bracelet which can be worn, and this recommends the change of lifestyle. So it will give the details of based on your status of your health, like your pulse rate, your hypertension, and the sugar level. So all those things can be checked, identified with wearable devices. With that, you'll be able to get the notifications for the change in lifestyle. Then based on that, you can take the precautions. So this can be directly connected to the iPhone. So with the different devices like smart specs, then the bracelet and watch, so different devices, so which can make use of our internet of things, which is digital health, then the telemedicine. So nowadays during the pandemic, this IoT has become a very prominent field to solve very severe problems at present scenario. Because so when the human cannot directly interact and go in touch the particular objects, you can make use of the robots. As you might have seen, drones have been used to identify or to locate the particular objects and human being. So as in the previous lockdown period. Okay, so same kind of devices or the internet of things can be used or to identify the solution for this COVID also. So these are the very simple examples what I have taken: smartwatch, smart specs, as well as bracelet. So with which you will be able to connect to our smartphone. In turn, smartphone is connected to the doctor who is prescribing the medicine for years, and based on the data sensed by the wearable devices, the doctor will identify and analyze, and the prescriptions are sent back to the mobile phone. So which is and also you can get it medicines by ordering. So that's what the digital health and telemedicine. Then the smart city is the one where the different devices like cars can be connect with your home, office, as well as uh, offices like general offices like a KB and different other general purpose offices where everything is getting connected. So that's what smart city is. Smart cities, here I can you can say that we can connect to different buildings, we can connect to different offices, we can connect it to the roads, we can connect it to the traveling vehicles. So what we can achieve with this? So everything can be automated. So best suitable example for this is the traffic management. Implementation of smart city for Bangalore is to realize or to predict the traffic scenario in Bangalore. So once the connected devices are able to collect the information through the sensor network from different part of the city, we'll be able to analyze and will provide the details to the user who is or the daily traveler on that particular route. So for that we require some other some other concepts or some other technologies where we can analyze it as well as predict. So there comes machine learning. But when the connectivity of the devices, electronic devices, and the sharing of only sensed data is can be done with Internet of Things. Then as a part of smart city, we can say smart home. So in smart home, we can automate everything. So where, as I gave the example, like the window monitoring or window controlling, home controlling with different operations like switching off a light and fans automatically, and everything can be programmed as well as your TV programs on for a particular period of timing or slots you can make it. So all those things can be automated, and no need to have any manual or human being intervention. Okay, so suppose if you give the scenario like from morning 6 to evening 7 o'clock, what are the operations you are doing regularly, like maintain tasks which can be programmed and set, and you can connect, or the for any kind of unusual situations you can activate notifications to your or give the options for notifications for your mobile phone. So as and when anything happens, then only notifications will come. Otherwise your daily routines will be done as per the program, so which you are fed for the IoT systems. In the sense, switching off your geyser at particular time, switching off your lights at particular time, and switching off your fans given time, and particular program switching on to switching on your TV for a particular program on particular slot or a particular time. So everything will be done automatically. No need to switch on or switch off manually. So that's what smart home is. So when smart home implementation is done, so one of the interesting, the future what we can have is smart ceiling. So we'll see in the next slide how smart ceiling can be implemented. So that is by knowing smart connected buildings. So convergence of building technologies to internet protocol, so where the data analysis can be done on cloud. So you can see here cloud management and analytics. So here we have a network where the different technologies or different electronic devices plays an important role is in IoT, that is IP telephony, IP cameras, then the building management systems using low voltage PoE, then the IP building systems on low voltage PoE. So all those are connected to for sensing, for ventilation, for lighting, and for all those operations. So how actually it was in the earlier, it was in 2005 it was only for PBX. Now in late 2000 it is only coaxial with cameras. Then the in 2010 it is building management, we can say, but in 2015 it is convergence of sensing, ventilation and light. So with these features we can design a digital ceiling. So this is how we can have in a smart home, digital ceiling can be implemented. So what are the infrastructure required for digital ceiling is, we need some lightning obviously, then the sensors are required. What kind of sensors? We require light, motion and carbon dioxide sensor, identification of CO2, that sensor is required. Then the building automation and all those components with Wi-Fi. Okay, so this is, we can say, the basic layer where the intelligent drivers are required, which will sense, then save that in network infrastructure. So with the network infrastructure where we have COPE as well as UPoE, PoE, etc. Then the data is available, or sensing data is available on network infrastructure, and the control systems are taken the data and analyzing it and providing the required operation, that is building management, then the energy management, then lighting control as I mentioned, so automatics, switching off and on. So this is about the framework for digital ceiling in smart cities. Again, in smart cities, smart connected, smart home and smart ceiling. So next is smart retail, so where we can have internet of retail, smart retail. So with as everybody is aware or already part of online shopping, so where the no, so again it is one of the best application for what we are using at present. As a in a pandemic situation, it has become one of the advantageous application of Internet of Things. So no need to go. So just you can order it, and digital transfer of money you can do and get the things or purchase the things. So that's what the smart retail. So IoT smart supply chain. So when we connect all those things, so we can say that is IoT supply chain. So so suppose you are for smart office, you may require some of the components where we have here you can mention. So you want to get connect with your planning as well as traveling and purchasing. So all those can be automated by connecting through internet. That is the meaning of IoT smart supply chain. So where the everything can be connected. Then what value it is added? So industry 4.0 IoT value chain. So it is a set of activities where the firm operating in a specific industry performs in order to deliver a valuable product for the market. So what kind of the value chain we can identify or observe here is, so end-to-end digital connection. So IoT enabled manufacturing, then the IoT service implementation, and IoT service operations. So if you see from the labeling one, that is connected products, so which is remote monitoring. So who is going to operate that? So that is with the marketing services. So we can get the value added for your service. Then the adaptive logistics, then the work environment, then sales and marketing. So here at the middle layer, we have the components. So which are, we can say, the part of the requirement. So finally, what we can achieve is the IoT's implementation as well as IoT service. So in industry 4.0, as I mentioned, Internet of Things. So how we can get connect with the devices and on the internet, what are the different components we need to know. So as like the industry revolution, there is again a web generation. So where we can have different versions, like web has started with the hypermedia link documents, as you can see here, World Wide Web. So when I say, when I am able to get connect with my phone to the internet, but where I need to know what kind of GUI is required and where to place the order and where to transfer the money. So all those different components which need to be known for each and every IoT device operator. So for that, the different components which are involved in these transactions with respect to web are hypermedia, which are interlinked documents, so which is World Wide Web. The next Web 1.0, so introduce or the enhanced of that is multimedia, so which is interlinked media, where so you can see the applications with Google, Amazon. Then the technologies or the programming what we are using for Web 1.0 is Java, UML, and XML. So as Java, UML, and XML is, Java is object-oriented programming. So where the, so till now 2020 or 19, the before Python program was introduced. So Java is the main program for each and every application. So Java is being used, so including big data analytics. So UML is Unified Modeling Language and Extended Markup Language. So these are used to connect different devices as multimedia. Multimedia in the sense we can connect either audio, video, or convergence of both. So Web 2.0 can be defined as web services on social media that is interlink people. So nowadays we can link with the people with Facebook, YouTube, as well as Twitter. So as you can see in the diagram, then the app technologies, so which are social media interlinked enterprises, so where we have Facebook, LinkedIn, so Yahoo, Google, all those things. then Chrome. Then finally, cyber physical media, that is interlinked system, is for IoT and IoT. So these are some of the applications, because if I start IoT architecture directly, so it will be very difficult for you to analyze. So what I have given is introduction to Industry 4.0, then Internet of Things, then computer network and internet protocol. Then next is what is the IoT architecture. So how it has been designed, or what are the core components required to operate with IoT architecture. But before that, we have studied what are the different applications, because we need to know when and why we are using Internet of Things. For that, the applications have been explained. Right now, IoT architecture, in brief, I would like to tell you what are the main components of IoT architecture. So basic thing is, as I mentioned, sensor networks, so which connects different devices, those are called as things. That is the basic layer. On top of that, we need to communicate to the cloud through internet. So that's what we require, gateway. So where in things we have sensors, actuators, then IoT enabled devices, then mesh networks. Sensors, actuators, sensors will observe or will read the values of the environmental changes. Based on that, actuators will act. So that is another kind of electronic device, so which can be added. Then the IoT enabled devices, so which can be connected to the mesh networks. So after understanding only hardware part of this, then what the things can do is, things can identify with the sensor network, will identify the change of values in real environment, and those values are collected and sent to the, or it need to be sent to the cloud. Why cloud? Because that data need to be analyzed, so for that cloud is required. So that's what the big data is also very, very important, because when I say things, so number of devices are connected, the things are connecting means more number of according to the statistics, 1:8, one person can connect with the 8 devices, means the operation on the internet you can imagine. So all those data are generated, means it is huge. That's what the big data is. So when the data is generated, need to be analyzed. It cannot be analyzed with the sensor network, because the sensor networks are very small and you cannot do any kind of execution operations. So only sensing the data that can be analyzed at the cloud, or at the fog scenario. So we'll see what is the meaning of that. So in between we have a gateway which can collect the data from the things. So where we have Thread, Bluetooth and Zigbee. So these are the connecting devices, connecting networks with the Internet of Things devices. The data is sent to cloud or forwarded to cloud. So which is cloud can be connected with edge computing. So what is the meaning of edge computing is, so through the gateways, directly the data will not be uploaded to the cloud, but via it can be uploaded to edge computing. The meaning of edge computing is the execution of that, which is similar to fog computing. So here the execution or the operation, anything will not be performed here, but that is performed near to the things network. Means the operation is executed near to the things, means this network. So that is called as edge computing, and finally that data will be uploaded to the cloud. So in detail to understand, as I mentioned, 3 layers. One is things, second one is gateways, and the third one is cloud. So with which the IoT architecture, which is defined by the word forum, is like this. So in this architecture, we have physical devices at the bottom, then we require connectivity, then we require edge computing, that is data element analysis, then the data accumulation, data abstraction, then the application, collaboration and process. So as you can see here, this is the exactly how we can operate with Internet of Things objects, edges here. So where we can collect the data and some sort of processing can be done at this stage, that is called as edge computing. So when more analysis is done, or that data can be directly sent to this cloud, so which is called as where we can also say data center. So in between we have transferring transferring networks, where Zigbee is one of that. Then the data aggregation is done, and finally it will send for the cloud for the analysis. So this is the explanation of physical devices, where we can say the layer 1 is meant for physical devices and controllers. So where the different devices are connected, and we can say those are the things. Second one is the connectivity layer. So in connectivity layer, we can say, see, this is the connectivity layer. So where different networks as well as device network infrastructure, which is being used to connect smart devices to the cloud. Then again, continuation of connectivity. Sorry. Continuity of second layer, that is connectivity layer, is here we have the devices. So as I mentioned, Zigbee is one of the network, and with that we have communications of layer 1 devices, switching and routing, then the translation between protocols and network level security. So all these operations are being done at this second level. Then layer 3 is defined as edge computing. So as edge computing is after collecting the data from the smart systems via networking, the data analysis of, or the smaller data analysis is done, so which is called as edge computing. So in edge computing, so which is also called as a fog computing, so we can see here that is evaluate and reformat. See, suppose the data collected need to be reformatted to analyze, finally to analyze or to come to the conclusion at the top layer, so which is big data analysis, or we can say analytical layer, so where we can find this as collaboration and process. So for that, the data is being reformatted. That kind of operations can be done in fog or edge computing. And finally, 4 to 7 layers, as it is mentioned, data accumulation. So general term is, here we can see identify storage device. So physical storage device or cloud as a storage service, we can save the accumulated data. So how to understand this? Suppose if I say only simple sensor network is there and 5 to 6 sensors are there, and the accumulation of data is very small. But suppose you think that all over, take a scenario or one case study where if you want to save the details of the patient who got infected with coronavirus. So how you are going to do that? So this is how. From the different part of the world, you are collecting the data from, as you are aware, Arogya Setu is the one of the applications where we are using. You can identify where also data is uploaded. So when the data is updated, that need to be sent to the edge computing. Then here you edge computing will collect and reframe it. If any additional or some kind of unwanted data is, filtering of that data, it can also be done at edge computing, and data accumulation is done at the storage device. So where means we can say the in the cloud also storage as a service. If we consider that that as a service from cloud, we can say the data can be saved here. Then the abstraction of that, abstraction again, you can filter it as it is, the data cannot be. So suppose if you want to identify how many of data abstraction can be done in with different things. So suppose with respect to COVID patient identification of all over world, so how we are proceeding with. So at a time you may not require all the parameters, but first you want to identify how many people got infected. So for that, the data abstraction only to identify whether infected or not. So later you may require that for how many based on the ages, or how many based on the prehistory of the different diseases. All those things can be done. So that's what data abstraction is. then that can be sent to the analytics. So analytics as well as control. So where we can develop application and which can be collaborated. So this is how the simplification of the layers 4 to 7. And as we cannot understand all the protocols in detail, just only to know what are the different protocols, just to remember IoT protocols, we can say constrained application protocol, which is called as a COAP. So why it is called as a constraint? Because so one of the main issue in sensor network or IoT is it is with the energy of the sensing devices. So those devices are having lesser energy. We cannot recharge it. That is again one more constraint. So in order to achieve or in order to overcome all these constraints and execute the data, so we need to have the protocol in such a way that so we can operate with the possible operation, means with identifying the best possible options, and we can operate. So for that we need to know that's what the COAP is, constrained application protocol. So with that message queue telemetry transport protocol, then advanced message queuing protocol, and data distribution services. Just to mention a name of the protocols I have added. Now I'm not going to discuss in detail. So then what are the different IoT technologies as I mentioned? So we require different electronic devices. We require one network, either it could be Wi-Fi or Zigbee or Bluetooth. So how you can connect with the internet with either wireless or different kind of networks. So this is how the technologies required for IoT are RFID, Wi-Fi, IEEE 802.11, then the barcode and QR code. So barcode and QR code, which already you have been using nowadays, again during the pandemic. So for QR code is being used for any kind of the shopping or any kind of means digital operations. Then Zigbee, IEEE 802.15.4, then obviously sensors and smartphones. So these are the different technologies which are playing important role in Internet of Things. So as I mentioned, RFD, so which has been used in transportation and logistics, where the radio frequency identifier is being used by identifying the barcode, so we can see the value. And this is the network, so as everybody is familiar, and how the barcode looks and what are the advantages. It is for low cost, and then the several devices can be easily implemented. Then the QR code, so which is quick response code, so which is very common, so widely used in both indoor and outdoor. As already you are acquainted with this, no need to tell. So this is like Zigbee is another network where we can connect our IoT device. So what is the specific feature of this is it is very easy to deploy. Then the large number of nodes can be connected up to 64,770. Then can be used globally, and it can be implemented or it can be used very easily in a secured manner. So then the different sensors which we are daily operating on our mobile phones. So as you can observe here, so we have sensors with that. So we'll be operating different operations. Then Autobot is another diagnostics service for cars, where alerts of relatives in case of an accident we can get it, and discovery service for car position, as well as integrated with several web services. That's what we have seen why the integration of IoT component or IoT devices required with web, because without only sensing the data, saving it in your mobile phone cannot work out. It needs to be opened and analyzed. So for that we need to interface with web, so where the web services are required. So that's what the web of things. Now IoT can be again defined as web of things, because everything can be connected to internet, that is internet of things. When the internet of things sends the data where it need to be visualized, that is on the web. That's what it is. It can be called as web of things. And as per the statistics, the general means the survey, it shows that the on an average 1 million new user per day come or join to online, that is to the getting connected to the internet. 57 of the world's population is now connected. See here, almost more than the half of the population is connected with the internet. Then 2/3 of the world's population are mobile users. 2/3 of the population is mobile users, and 55% of all active connections come from mobile. So now, as we started, or in the industry, IT industry, we started computer networking, but now the convergence happened in such a way that any applications can be operated on mobile phones. So mobile phones are become more active and more popular electronic devices for Internet of Things. Then what and all the things or the softwares we require for Web of the Things is Hypertext Transfer Protocol, Transmission Control Protocol, then IPv6. This is actually the important uh, important protocol, because without internet we cannot have Internet of Things, we cannot have cloud computing. So on top of that, we cannot do any big data analytics, machine learning, artificial intelligence, any other things. Core requirement for us to get connect with the different technologies is internet. That is possible only with IPv6. Then the XML, so which are the web developing tools or softwares with which you can interface. Then what are the challenges? As I said, the different kind of devices can be connected. So obviously challenges are there because the privacy we cannot have. So when the data is generated, it is uploaded to the cloud, or when you're sharing to the social media, it is not at all private of data of yours. Then the security is when your data has been uploaded to any social media or any of the electronic devices, if that is hampered or misused in different way, then it is a security threat for your data. So then how to make use or how to protect your data with different architecture systems are connected. So that has become one of the challenge in IoT. Then the big data and data analytics, because as huge data, as per the statistics, so more than 50% of the people of the world population are getting or have connected with the internet, and the data you cannot imagine that the daily the data generated. Then out of that data generated, how you can analyze it as a big data. Then out of that, what kind of business intelligence can be generated, and how it can be used for the business enhancement with a business or data prediction. So that's how the big data and data analytics, because the huge data is generated with different architecture systems. So the format of the data is different, and that need to be consolidated, and that need to be analyzed properly, and finally out of that we need to get the meaningful output. So interoperability is, so again, the different systems. Recently I was standards are helping minimizing this problem, but still, so as the interoperability is, so nowadays there is no restriction for any device which cannot connect to the internet, as long as the device is able to communicate. So it may be having any kind of different architecture, different vendor. So all those standards need to be met, and it can be operate as a common platform or a single platform. So the future of IoT is where the word sensor networks, then the home automation will be enhanced. Your life or everybody's life will be easier. So where everything is automated, it will be very easy. But tracking and shipping of goods is also used in transportation, and it can be very well used with farming as well as health. Then for unpredictable developments like the pandemic situation like COVID, so IoT is still is using as the best tool. So with that, I'm concluding what is Internet of Things, then how the IoT is played important role in our daily life. So as the time permits, I would like to complete this big data. So as you have seen the different devices, and also you might have got an idea that the generation of data with different devices, right? So huge data is generated. So that according to the Gardner, who is a famous scientist about in big data and in IT industry, has defined as big data as it is a high volume, velocity and variety information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision making. So, why everybody is mentioning the field as big data? Meaning is the data which is generated by different devices need to be analyzed, need to be taken for further for prediction or to enhance the business or enhance the business profit. So in order to achieve all those things, we need to know what is big data. So in general definition, we can say it is unstructured. Meaning of unstructured is your data, because the before going to that, let me tell you what is the difference between structured and unstructured data. Then when we say structured data, then why structured data is required and what is big data. Structured data is, as you might have studied in database management system, so where the number of rows or number of columns are created in a database software. Okay, so what is the advantage of that? It's very easy to use, and you can modify the data, you can retrieve the data with a structured query language, and you can interface with any front-end tools where you can retrieve the data very easily. That's how you can develop any kind of applications by using any object-oriented programming with Oracle or Java with Oracle, or any kind of GUI-based front-end, as well as database management system as a back-end tool. Okay, that is structured data. Why unstructured? Because in unstructured, here the data generated from the different devices may not be in the same form. So it is in some text form, it is in a table form, it is in only some numerical form. So all those data need to be analyzed properly. That's what we can say big data analytics is required. So what is the key requirement to understand this is, since the data is generated by the different devices, different forms, so we have big data. Okay, then what are the main characteristics of big data? It is huge volume, means volume is big. As the more devices are connected, more data is generated, obviously volume is more. Then the velocity, the rate of data generation. So as I said, how you do I identify velocity? Because how many number of users are getting connected daily? That statistics we have seen in the previous slide. So when more number of devices are getting connected, the velocity of the data generating on the internet or on any platform like a cloud, so it will be huge. So we need to analyze that. For that, it is defined as one of the V of big data is velocity. Then the variety. Variety is different kind of data, not same kind of data. Means that's what it is. Unstructured. It is not in a particular form. It can be either any normal formula based, or it is a text based, or it is audio or video, any kind of data. So this is how we can see the data volume, data sources. What are the data sources? We can get it from sensors, RFIDs, then the devices, web servers, right, and mobile phones and our systems. Then the data volume, where we can save the data on storage devices, but this is the size. Earlier we used to talk about terabytes and petabytes. Now it is zettabytes. So the non-traditional data types can also be used, like blogs, text, chats. So that is different form of, that is variety of data. Then the technologies which are being used is highly scalable in the sense, as it works for the smaller data, it need to be applicable for the huge data. Then the acid free approach, meaning of atomic, then the consistency, isolation, and durability. So apart from these basic properties of database, we need to have the data which is with we need to check the data with different approach. Then the economics is optimized business analytic solutions. So the collected data from different sources can be called in terms of zettabytes, right? Then the that is in a form of blogs, images, videos, etc. Then the technologies can be used to to execute, so which are scalable. So to see this in a clear picture, we can say the big data is as data we have mobile internet usage, video, social media. See here, this is the first layer. From here we can get the data. Then the technologies are collect, integrate, process, and aggregate and visualize. See, the steps in analyzing big data is, the first step is collecting the data. Second is integrating. So because I may get the data from the mobile internet, I may get the data from my mobile phone or any form of a source or from different source. Then I can integrate that. So once the integration of data is done, that's what we can enter into process. So when the process is means a process, the data is based on your requirement, you need to apply the algorithms, then start processing. Then the aggregators, the based on the again requirement, aggregation of the data can be done. So sometimes the huge data which is collected may not be required to visualize or to predict for any business intelligence. So in that case, aggregation of data need to be done. So this is at the end we need to visualize. So always visualization is the final part or the step where we can see what exactly the output is. So for the visualization, again, we need different tools in big data analytics. So where the visualization plays important role, because so by seeing only the data, you will be able to identify, we can predict. Means I mean to say it is graphs, so which are the part of visualization. So in the analysis, we can have a descriptive, means what is happening, then the diagnostic, why did it happen, then the predictive, we can say what is likely to happen, then the predictive, prescriptive is what should do about it. So these are the steps after collecting the data, after analyzing the means the collecting, aggregating the data, so finally analysis. So what we can see as a big data is, it is a heterogeneous data generated by different sources. That's how we can see. And here, by analyzing that, you can come to the conclusion, or you can get the required information. Then most of the big data technologies which are being used in the year 2020. So this is again next one big field, but just I would like to give brief introduction about all those things, because IoT and big data both are related. So for that only I have taken this as a topic. So let me complete this one in brief. So that is, what are the technologies we have for big data analytics? As you can see here, Hadoop, so which is one of the best big data analytical tool, and which uses distributed file system, and also it executes very fast. Then the NoSQL as SQL, structured query language. Here we have NoSQL. So for SQL is being used for structured data, and NoSQL for unstructured data. So we are not framing any SQL type of statements, but another logic which can be used in NoSQL to retrieve the data. And some of the important tools which can be used for big data analytics is Apache Spark. So that is again one of the major field. Then artificial intelligence, so one of the important field, means how the big data is related to artificial intelligence. Then R is a tool So with which easily we'll be able to analyze it, and as well as we can visualize it. So that gives the platform to execute parallelly. And the next is the visualization part, where you can display your results. So for when the visualization is not possible with some of the tools, we can interface that with the visualization. That is also one of the important tool for big data analytics. So I am going to explain this Apache Hadoop, because Hadoop is one of the best platform to analyze big data. What is the ecosystem of Apache Hadoop is? The first one is distributed file system. So, and here we have uh, three main components. One is HDFS, another one is YARN, I have not mentioned here, and the third one is map reduce. So as it is based on key pair process in map reduce, it is analyzed, means the analytical takes place with a map reduce on the processing unit as a yarn. Then what is HDFS? It is Hadoop distributed file system. So as you are aware, the file system is the one which is required for each and every operation. So as we are using Windows or Linux, so every operating systems are having their own or its own operating system. Means operating system has its own file system. So either it could be network file system or a flat file system. And here for big data analytics, it is HDFS, distributed file system. What is the meaning of distributed file system? Is here the data is divided on different files on different servers. So because Hadoop creates a number of nodes, so which are called as name nodes and data nodes. On that architecture, the distributed file, in the sense the data will be just segregated based on the blocks. So suppose 10 KB is our data, that is equally 5 KB blocks are created, suppose, then it is distributed among different systems. It is not executing on a single file. It is executing on different nodes with distributed file system, so that it can execute very fast and give the result quickly. So what is the scenario in this case is, once it is distributed, in the sense the sequence of the output we are not getting on a single node, so that need to be integrated again. That's what we require map and reduce. So that is done with map and reduce, so which is the main component of Hadoop ecosystem. So we can also, so this is about the brief about Hadoop ecosystem, yeah, role of Hadoop ecosystem in big data analytics. So to analyze your data, even Excel can be used as an analytical tool, because in Excel you can create a number of, you can enter number of data with tables, and also visualization can be done with the graphs. So that can be integrated with the front end. Like you can create MS Word as a front end and import all the data or the uh, graphs which have been generated based on their data in Excel. So that is how the analysis can also be done in Excel. So as I mentioned, NoSQL, so which is not only SQL. So where this can be used for unstructured data. Then R programming is, it is an open source programming language. As I mentioned, on a single platform, you will be able to execute as well as visualize. Then, so this is very less brief about the big data analytics. Okay, suppose it requires one more session actually for big data analytics, only as it is related to IoT. So just I wanted to give the brief introduction. Then what are the challenges of this big data analytics? So in big data analytics, we have a challenge of data storage and management. So as huge data is there, and the management of data is difficult because it is unstructured. Then visualization. So we need to identify which is the key or prominent field for that particular data. So as if you compare with normal database management system, so where we are setting the relation between the number of different files or tables, right? The each and every file is identified with its primary key. So that will derive the other information of that table. So when that table can be connected with different tables, so where we can have a relational database management system, so it made the operation very easy with the structured database. But when it relates to big data, then it's the identification of the uh, key value of that data as well as form of that data, and how to predict as well as present the visualization. That is become one of the main challenge of the data. Second is confidentiality and privacy. So as the same thing what observed with respect to exclusive IoT, here also confidentiality and privacy. So when the IoT device collects the data, it is nowhere a private data. So when you share it with the net. So integrity is connected devices are uh, proficient in sensing, communicating, on sharing, but the data integrity should not be uh, missed, or always it has to maintain the data integrity. Then the power captivity is equipped with a device connected with unending power supply of the smooth and continuous function of IoT operations. As one of the major challenge with IoT is the power parameter, because the sensor networks, which are very small energy consuming devices, as well as the small devices, the energy is one of the constraint. So that is become again challenge in IoT big data analytics. So this is how we can see as the IoT as well as big data as a role in industry 4.0. So as in the first slide I mentioned, industry 4.0 is integration of all these fields. So where we have first the sensing. With the sensing we can say Internet of Things. Internet of Things data can be shared to cloud. Then the cloud can be cloud data can be used for the analytics. That's what the big data analytics. So when the data is analyzed, how it can be used. So that's how you can apply to machines. The next field, what we can say, machine learning with artificial intelligence. When the machine learn the data properly, then we can generate intelligence. That's what the artificial intelligence is. So what actually, as it is related, so just I would like to give some information. AI is a ruling field in industry 4.0. How artificial intelligence is intelligence works. So again, if you want to see the application of this is like robotics. Robotics can be used in our daily life. Thing is, wherever human intervention is difficult, we can make use of robotics. Again, technology playing important role in pandemic situation. In some of the countries in the world, are robotics being used to treat COVID infected patients. So where human being cannot reach, the robots can be used. Then how these robots are programmed, that is with uh, the integration of all the sensor networks, machine learning algorithms, then data they generated is big data. So that's how the artificial intelligence is playing an important role. So only to understand the part of artificial intelligence, which is a machine learning, so we can say supervised learning as well as unsupervised learning and reinforcement learning. So why machine learning is required? That is to train our system. When the systems are trained, so we can say those systems can act as the agent of artificial intelligence, and those can be used as a robots. Okay, so to train our system, we require some of learning techniques, so which are supervised, unsupervised, as well as reinforcement. So as the name only says that supervised is the training the system with supervision, right? Unsupervised is training the system without any supervision. In the sense, the predefined algorithms are given for supervised learning, but the situations, based on the situations, the algorithms can be reacted, that is in unsupervised learning. The reinforcement learning is combination of both supervised and unsupervised learning, so where we can have the algorithms like for clustering as well as association. Okay, so this is how to simply understand the meaning of machine learning, so where in order to achieve the artificial intelligence. So these are some of the algorithms so which are used for supervised learning, linear regression, random forest, and support vector machines. So I'm not going to explain, just mentioning unsupervised learning and the reinforcement learning. Okay, so the final conclusion is the role of IoT as well as big data in industry 4.0. So in industry 4.0, what requires is, it requires comprehensive digitization of the horizontal and vertical value chains. So as we have seen, horizontal as well, we have seen value chains. So how we can say horizontal and vertical? So when I say horizontal is, it is connected with the supplier, company, as well as customer. So when you say vertical, so it is with the company. So all the parameters or parts of the company. So in horizontal, we can say from the network of customers, we can connect to the planning, means that is the company. So where we have purchasing, manufacturing, and logistics. Then the supplier is the network of suppliers as well as corporation partners. So this is called as horizontal value chain networking, and this is vertical value chain networking. So in order to achieve the value chain in industry 4.0 with respect to internet of things and big data analytics, so we need to know the core areas of individual value chain, then the reduction of redundancies, then the minimizing quality losses, then minimizing the value losses. So these are the important, making process more flexible and coherent. So in order to achieve all these things, so we need to know the role of, again, IoT and big data. So to understand industry 4.0, the remaining technologies what it is mentioned in the first slide, sorry, we need to know. Right. So as an academician, what it makes us is to achieve or to add a value to our students to become a part of industry 4.0, because each and every student need to know what is IoT, big data, cloud computing, all those things. So apart from the technology, I am talking about how we can train our students to equip with all these technologies. Because earlier it was like only the technology, like anyone programming, you can become a system programmer. If you know any application development, you can say develop like that. But now in industry 4.0, it is an integration of all the fields. So as the technology is also enhanced or evolved, the requirement of the upskilling for our students as well as everyone who are part of IT industry is also increased. So in order to achieve that, so we need to always cope up with the industry requirements, as the industry requirement is IoT's big data and all those things. So in our college, like Don Bosco Institute of Technologies, we have our own incubation center, like the IoT lab, where different IoT projects have been implementing, and we are training our students to take part for the IoT project exhibition, and also we got the sanction in KSCST for IoT projects. So like that, we are encouraging our students to enhance their skills with respect to Industry 4.0. Then we have our own research. For the research purpose, we have our data center, so which is in association with Upstream Technologies. So in our college premise itself, we have a data center where the students are also getting trained, and they are able to understand the infrastructure of data center, then the data, how the data center can be being used as a part of cloud computing. So all those technologies are directly training to the students. And as a part of so in order to achieve all those things, we need to be associated with industries. So as industries are the core where the implementations are happening. So one of the industry interaction program with UiPath in association with GUI. So as our college is also participated in National Skillathon, and our so 504 students got the certifications. And also we have the interaction with Delhi EMC for, and the 37 students got the data certification, data science certification in the year 2018. And also we, students are upgrading their skills with respect to Salesforce cloud, and with a Salesforce platform, our students are upskilling themselves and securing virtual badges. And also obviously the Infosys, so which of the one of the largest participants in our Campus Connect. So we have a Infosys Campus Connect programs. So with all these things, we are training our students to equip with for Industry 4.0. So to conclude this, so as I have mentioned, the IoT, big data analytics, cloud computing, robotics, and all those things. In order to achieve that, we need to update our skills, as well as we need to motivate our students to update themselves, so that they can develop the projects which are based on robotics. So robotics cannot be implemented directly. So for that, they have to go through wireless sensor network study, as well as the machine learning, then finally artificial intelligence. So all those things are required to study in step by step. It is not directly the implementation of artificial. So no doubt there are some students who are very extraordinary can do that, but still it's very well, or it's very good, so that you can understand the technology enhancement from the beginning, from the computer network to artificial intelligence. That's what my intention is. For that only I have taken two major fields of Industry 4.0. Okay, so with this, see, without the help of internet as well as Google and all the papers and all the authors who have and the website without which we cannot get the information. So these are the references what I have referred. So this is for the users who want to refer, they can make use of this and understand in detail. So thanks for your attention. Thank you very much. If you have any queries, you can open for questions.
So thank you, ma'am. That was wonderful and enlightening talk. We were aware that only basics of IoT, but your talk has thrown light on various applications of IoT. I'm sure that participants have benefited immensely from this session. Thank you, ma'am.
Thank you.
So now we have come to end of the session. On the behalf of management, the institution and the organizers, I thank speaker of today's webinar, Dr. Anasuya N. Jadagerimath, for sharing their knowledge with us. I'm very thankful to Professor Vijay Kumar A.S., Coordinator, Department of BCA, for successfully organizing this webinar. I thank faculty members of BCA for helping to organize this webinar. The response we got for this webinar was amazing. It is your active participation which motivates us to conduct more webinars. So our next webinar is on 29th of July, titled Mathematica, the only place where maths is easy, timing from 11 a.m. to 12:30 p.m. and the registration link will be shared through mail. From the bottom of my heart, I thank all the participants for making this webinar a success. Thank you, one and all. Thank you.
Thank you.